Hello, this is Hazel from C-Trax Customer Support. This is a very brief overview of XL Designer to show you how to create a printed circuit board from scratch, starting with the schematic capture process. Other videos will cover each of the topics in more detail. On the screen in front of you, you see XL Designer as it's been run up. Across the top you've got the title bar showing you the program name and what version of software is actually in use. Underneath, the command bar with shortcut icons to some of those commands. Then we have the navigator pane, which is always got the masters folder within it. Underneath there, the browser and the properties pane. Within the masters folder, you've got everything that sets the system up, and when you create a new design, information from the masters folder is copied into the design so that you've got a template to start working with. So we'll create a new design. Just select the icon for the new design and you get a new folder within the navigator pane that represents the new design. If we expand that folder, we see all the elements that make up the job or the design. So you can see it's got the schematic, component outlines, board profile parts, net lists, everything is within there. So the first thing we need to do is create a new schematic sheet. So we right click on the schematic folder and then we've got various options to create new things, and we want to create a new design sheet to start with. So we give it a name and then double click on it to open it up, and you see in front of you the design sheet that's automatically generated. If we just maximize the window, put the cursor somewhere within the editing area and press the function key F4, and that will just maximize the area that you've got to work in. The first thing that we'll want to do is add some schematic parts. So we use the symbol place icon command or the icon for placing symbols. And we've got to choose a symbol to place, and because the job is new, there are no parts within it so far, so we go up to the masters folder and expand the schematic library folder, and these are all folders containing lots of information, lots of schematic parts that we've supplied with the software. Just expanding any of them shows you what's available within each folder. So I need a transistor to start with on this little amplifier. So we expand the transistors folder, and again, when you select a component, you get information down in the properties pane relating to that part. And if we look at the browser, then you see the schematic part as well. Now I need an NPN transistor. Just select it and then move your cursor over onto the screen. And then if we zoom in using the function key or the scroll wheel on the mouse, you can then just plop your component down. If you want more of them, you just carry on. If you want something else, you just come over to the library and pick up the things that you do want. So I want some resistors. We'll have a surface mount resistor, so R0805 calls up a resistor that uses a footprint 0805. When we move onto the screen, press the R key on the keyboard, we'll rotate the component, and then we can just drop some resistors down. And I will also want a capacitor. And then we need to just start adding some wires. So we either use the shortcut icon for add wires, or under wires insert connection. And then we zoom in again if you want to, start the wire on a terminal and then release it on another terminal. You'll see the little crosses disappear to show that the connection has been made correctly. Whilst we're zoomed in, I'll just talk about the text that you see on the screen, when you place the parts from the library, they don't have any component reference numbers or pin numbers assigned, and we use the allocation commands to allocate that information. So you can either do it on an individual basis just by selecting a component and clicking on it with the left button, or we can use the automatic allocation and we just allocate everything. And then if we zoom out or pan, you'll see all the parts have been given part reference numbers and component pin numbers. So carrying on to add some wires. You can drop a wire in on an existing connection and you'll get a little junction blob created automatically for you. Wires can be dropped in the middle of nowhere if you want to. And what we'll do is we'll assign a signal name to some of these connections. You can make the circuit diagram look prettier if you want to. You can move symbols, then the wires automatically rubber band. You can rotate them using the R key on the keyboard. Delete some, we don't want those components, so we just delete those. And I want to add some signal names now, so we use wires, attributes, add. Select the connection, and you've got various attributes that can be added. We're just going to concentrate on the signal names for the moment, and we'll call this out 1. If we zoom in on the function key F2, you can see more clearly. And then here we'll call this one V+, and then down the bottom V-. Other things you can do on the schematic, you may want to change the value of a resistor, so we use the symbol attributes edit command, point at the attribute you want to change and just retype the value. Attributes can be picked up and moved, rotated. You can hide the attributes if you don't want them, so for example the pin numbers, you may not want to actually see them on non-polarized components, so you can hide them. It's probably easier or quicker to do that in the library part, so rather than show the pin numbers, just when you create the library part, don't make them visible. Right, so what else can I show you? You've got various commands, region move, if you want to just squash everything up a little bit. We've got quite a large sheet at the moment, which is probably a little bit too large for the circuit diagram that we're working on, so if we use the edit preferences command, the sheet size tab, we can just change the sheet size to a smaller or larger one, or a user-defined sheet if that's what you prefer. We'll just use an A4. And it will automatically create a new border for me. So there is a little circuit diagram, and the last thing we need to do in order to create the parts and wiring list is extract the parts and net list from it. So we've got an icon, a shortcut icon, extract parts and nets, and then this is the list of parts from this little circuit diagram. Gives you the part reference numbers, the values and the type of components, and what footprints are called up. And then if we look at the wires list, you've got the point-to-point connections that have been generated along with the signal names if assigned, and if a signal name's not been given, it just gives a reference number for ID. So that's the schematic exercise complete. Before we move on, one good idea would be to actually save the design that we've been working on. So it's still untitled in the navigator, so we just right click on the design folder and then use the save or save as command, and then you can navigate using your normal Windows navigation commands and provide a design name. So now the job has got a name and can be referred back to at some later stage. So we're now ready to move on to the artwork design. So the first thing we need to do is define an area for the PCB artwork. So double click on the board profile editor from the navigator to open up an editor. Different icons across the top. What we'll do is start off with a little rectangle. Specify the width and the height, and then just drop it down onto the suggested lower left corner of your board, which is notified by that little circle and cross. You can modify the profile. Now for this little exercise I'm not too bothered about the size of the board or its shape or anything, but you've got various commands to adjust the profile. You can add and move corners. There's also a numeric editor, so if you've got the shape drawn in, you can identify any of the coordinates on the edge of the profile, and then if you want to make an adjustment you can just type in a new value. You can also import DXF files into the board profile editor. If you've got complex shapes that have been defined elsewhere, they will just come in for you. There's also a library of board profiles which is empty when you load the software, because everyone's profiles are slightly different. But just as an example, up in the board profile editor I've got some just obviously different profiles from jobs that I've worked on in the past. It's just an example of a more complex profile. So back to this little design we're working on. That's the board profile. Define, you can add in keep out areas if you've got cutouts and things within the board. You'll notice the cursor is snapping to the grid or the half grid. And as we zoom in, the grid is shown up here, and it's in inches at the moment. You can change it so that you work in metric values. So now it's a 2mm grid, and as you zoom in, notice that the grid gets finer, and then as we zoom out it gets coarser again. You've also got the ability to set a fixed grid of 1mm or a 0.1 of an inch, or a user defined grid where you specify the pitch that you want in inches. You don't have to work with the grid if you don't want to. There's a snap to grid switch, so you can just switch it off so nothing will snap to anything, and you can also make the grid invisible if you want to, just by pressing the G key on the keyboard. So we're now ready to start designing the artwork. One of the things that you will want to do is separate your power tracks from your signal connections, so that power tracks are thicker than the signals, and if they're auto-routed, they are auto-routed with different algorithms. They can be put onto internal power planes. So in the configuration folder, power names table, just type in the names of the signals that you want to be treated as power rails. So just the V- and the V+ for this exercise. So we're ready to start the artwork design. Double click on artwork to open up the artwork editor. Again, pressing F4 in the main area, we'll just bring the item up to full size within the window. What we've got when you open up the artwork editor is, again, you've got icons across the top, but we've got additional controls down the right hand side and also on the left hand side of the editor. As we use these toolbars, or dialog bars, I'll explain what they do. So the first thing we'll want to do is presumably place some parts. Before we move on, one thing to check is that all the footprints that you need for the artwork design actually exist in the Jobs Component Outline library. Now, if we have a look at the parts list that was produced from the circuit diagram, you can see a table of information. Now, all the outlines that were called up by the schematic parts are listed here, and if any were highlighted in yellow, it would mean they didn't exist and that we'd have to create them before we could start working on the artwork. The other thing you can have a look at is in the net list. Just have a look to see whether any of the nodes are highlighted in yellow. Again, that indicates that you haven't got an outline with that particular pin that's needed. So it may be that you'd have to either create a new component outline or the footprint, or edit an existing outline to ensure it's got the correct number of pins. Now, all the outlines that were called up by parts from the schematic will have been automatically copied into the job, and they'll appear in the component outlines folder. And if we just have a look, we've got the 0805 footprint for the resistor, and you can just double click on it to open it up. And we can identify the pins, and it tells us what layer the pads are on and what particular size they are. There's a conventional capacitor and the TO18. So all the outlines we need, and everything is present and correct. So we can close those windows, or minimize those folders, and move on to the artwork editor. F4 function key to magnify the board up to the complete area. Before, again, something else you can have a look at is the layer assignments within the job. And you can see that we've got lots of layers available, and most of them are assigned to silkscreen. We've got the via holes on the V layer, and then we've got top and bottom copper layers. If you wanted to work on more layers, you just double click on a layer and then change its type to copper or power plane, split power plane, or whatever it is that you want to do. At the moment we'll just work with a double-sided board. Oops. So we'll leave that set as silkscreen. You can change the layers at any time through a design. You don't have to do it at the beginning because you might change your mind halfway through. We've looked at the power names, we've got all the outlines we need, so we can actually open the artwork editor. So double click on the artwork, or whilst I think about it, if you right click on the artwork, and then you've got the option to open it detached. So if you're working on a dual screen monitor, on a dual screen system, you can have the artwork open on one monitor and the schematic on the other if you want to, but I've only got single monitor, so we'll just double click on the artwork to open it up. Across the top you can see all the tabs of everything that I've opened, and you might find you want to close some of them down just to avoid cluttering up the screen. Entirely up to you. So here's the artwork editor open. When this editor opens, you get an additional dialog bar down the right hand side of the screen, and another on the left hand side of the editing area. This one will change depending on what command you've got selected at the top, and we'll go through all of those things as we proceed. So the first thing you'll want to do is to place some parts. Now there's a couple of ways you can place parts, but basically they've got to appear in the tray before they can be placed on the sheet or on the artwork. So we've got a parts place command, and then we can just use the add command. But quite often a nice way of working is to actually select the parts off the circuit, because if you're working in an area of a circuit you just want the parts within that area. So if we look at the region commands on the schematic, we've got add to artwork tray, and then you might just choose a few components, or in this instance we'll choose all the components. They go dotted to indicate that they've been selected, and so now we could go on to another part of the circuit and select some more, but we've only got those few at the moment. So pop the artwork forward and you see all of those parts have been added to the tray. So we're ready to place one, so select whichever component you want and it appears on the end of your cursor, and then zoom in if we want to and place it down. The next one from the list appears. Now when we drew the board profile we actually added a keep out area, if you remember, somewhere over here, and so it would be a good idea to see where that is, so we'll just switch on the keep out areas, so now we know not to put any components in that particular position. As the parts are placed you see the interconnections appear, and you can see on this component it's obviously joined to a power rail because the connection is a lot thicker than the signal wires that were added. And then as we move the components around you see the connections jump from one position to another. As you move the parts you'll always get the shortest connection length between the connected pins, so you can get a good idea of where's a good place to drop the component. You can press the R key to rotate it, so we'll utilise all the space we've got. You may find that the power tracks on this design are too thick for what we might want, so if we go up to the configuration folder and look at the manual routing parameters, this window controls what track sizes are used for signal connections and for your power connections, and the signals are coming in with a 0.254mm track size and the power 1.27. All the tracks are given code numbers just so you can refer to them, and so the power is code 11. So what we'll do is go to the size table now and look at the track width list and find the code 11, and we can see it's set to 1.27mm. So if we want to make that smaller, just double click on it and we'll make it 0.5mm. And now when we close that window, if you look at the thickness of your power tracks there, you'll see that they're automatically made smaller. Under the parts command you've got the ability to key move components, so if you've got for example mounting holes or a connector that needs to go in a certain location, you can select the part and type in the coordinates, and you can also change the angle, so if you want it at a peculiar angle on the board because you've got a round board or something like that, then you can use that command. And then when you rotate that component from now on, it's in 90 degree increments of that angle that you specified. Flipping components, we'll all swap them from one side of the board to the other. So if we use this surface mount component and just select it, it flips onto the back of the board, and the connections remain attached to it obviously. We can now pick it up and move it as before, just using the other mouse button when you've got parts that are on the bottom of the board. You can align components so that you, if we align X, you just select a position where you want them aligned and then just right click on the component to get them all lined up. Or I can undo that because I don't want them moved. Oops, parts. You can highlight the connections coming from a particular part. The renumbering routines allow you to renumber the parts from, say, top left to bottom right, or top right to bottom left on the artwork, and all of that information is back annotated to the schematic automatically, so your schematic and artwork are always in sync with one another. The part fix menu allows you to fix components in position, so if you've got like a connector or mounting holes that you don't want moved, you just fix them by selecting them, and then you won't accidentally pick them up and move them. Right, I think we're ready to start looking at routing the connections that we've got on the artwork. You can either auto-route the interconnections, or you can manually route them, or a combination of both. Quite often people might manually route the power lines in and then auto-route the signal connections. It depends on the design as to what approach you take. So if we are going to auto-route the design, we go up to the Tools command, auto-route, and then the router has got lots of algorithms for different types of connections, for the power rails, memory type connections, and then your general signal connections. We'll look at the setup of those on another video. And then the other thing you look at is the layers that you're going to be permitted to route on. So if you wanted to try and route single-sided, you'd switch off the top or the bottom rail, and then the router will only work on one side, but we'll just allow it to use two sides at the moment. If we'd allowed more layers in the configuration folder, then they would obviously appear here, and you would have the router will run on up to 6 layers at a time. So all you have to do is hit the All button, and the routing has started, and being such a small board, it's finished straight away. So what we might want to do is adjust some of the tracks it's put in, which will also show you how the manual routing tools work. So we'll go back to the placement and routing mode. If we zoom in, you can pick up a corner and move it, or add a corner. So if we right click on a track, the track stays attached to the cursor until we release it. You can move an existing corner and basically make a total mess like I'm doing, but just to show you what can be done. The layer swap command will allow you to swap tracks from side to side, and you can see the red tracks are on one side, and over here you can see that the top layer is the red layer and the bottom layer is the blue layer. And when you do the layer swap in, it automatically adds the through plated holes or vias between those tracks automatically. You can rip up a track using the rip up command, which is also under the MRoute menu, rip up there. And if we point at a track segment and use the right hand mouse button, it takes the track, the routed track, right back to a connection again. And so if you were manually routing a design, you just have all your interconnections like that, and you just use the MRoute corner command, or this icon here, and it's a right click to insert a track segment, and when it comes out of surface mount components, it'll only allow you to come out on the layer that the component is on. And then over here it tells you what layer is actually active. So if I now want to go on to the red layer, I can press the L key on the keyboard, and we've now got the active layer here, and so we can go on to the red layer. The via is automatically inserted, and then I can terminate the track on the pin. Sometimes you can tidy up what the router has done just by deleting some of the corners and moving a corner just to straighten things up a little bit. Under the view command, you've got net clearances. So if we zoom in on the tracks now, you've got a little bit of ghosting around the outside of the track that shows you how much clearance is needed on that particular net. And when you're routing on a large design and it's quite a lot of data on the screen. I mean, this design is so little that you can afford to have everything visible, but quite often you might want to switch off your component outlines and the labels, the part references that you see on the screen there. You can have the tracks shown, the pads shown filled or unfilled with the drill holes or not, as the case may be. If you want to see the pin numbers on components, if we bring the components back again, and the labels, it's quite handy sometimes if you're fault finding to know what the pin numbers are. Right, what else is there to show you? So we think we've routed this little design. So the next thing to do is actually run the check artwork to make sure that what we've got on the artwork corresponds to the connectivity that we've placed on the circuit diagram. So before we run the check, what we'll actually do is introduce an error. So we'll zoom in, and using the corner command, we'll just short those two tracks together, and then maybe up here introduce a clearance error so that the track is too close. Now we know where those errors are, but normally you obviously wouldn't. So the connectivity checker goes under the check command, and a window appears, and basically unless you specify otherwise, it's going to check against the sizes you've got in this window. So it's looking for a minimum of 0.254 millimeters clearance between signal connections and the same clearance for power connections, but you could increase that if you wanted to, or make it smaller or whatever. If you want to be informed if you violated any keep out areas, then obviously you include that check, and when we add copper fill later on, you can get that checked as well. So we're ready to go. Hit start, and it comes back with an error message. And so this is the design we're working on. It's got one clearance error found, no keep out violations found, but we have got a shorted signal, and it's the out one signal is shorted to the unnamed signal between those pins, and it's detected the short at the XY location given, and it's flagged it. So if we close this window and close the check window, you can see you've got a little flag here and a little flag there, and this one's got an S inside it because it's a short circuit. So if we just correct that error and then go up and look at the gap error, and then run the check again. You should always run the checks again, even if you think, oh, I've sorted that out and there's nothing wrong, just in case by moving something you've introduced another error. So we've run it again, and it says the artwork check is complete and we've got no errors found. So we know that this little job, the artwork matches the circuit diagram. So you could now go out and produce your photo plot files or send it off to the printer or whatever you want to do. But there are a few other things you might want to have a look at, and one of them is adding maximum copper areas on the design. To access the copper fill commands, we go up to the copper fill icon, and the first thing we need to do is specify a perimeter for the copper fill to fill within. So we can either put a polygon around the outside of the board, and then it will just use the board profile as its working area, or we can specify a little area inside. This dialog bar now controls how the fill is added. So the fill is going to be added onto the top layer of the board, and these parameters control the sizes and the clearances that are required. So just use the fill connect to net icon. V+ is the signal we're going to join to, and then the copper fill is added. And if we zoom in, you can see if we turn off the blue layer, then you can see a little bit more clearly. Any pins that are joined to the V+ net have got a little heat relief connection, and anything that's not joined to the copper V+ has got an anti-pad around it, but you can't see that very clearly because of the net clearances that we've made visible. So I'll switch those off, and that makes it a lot clearer. So there you have the copper fill just flooding the entire board and avoiding the keep out area and any tracks that are passing through. So copper fill's been added. Something else you would probably do is generate the silk screen for the design. So we'll have a look at that now. The outlines that you see on the screen here, which we can just switch off along with the labels, the part reference numbers, are just a graphical representation of the silk screen. It doesn't exist as a layer on the board at this stage, so I'm going to switch them off, and we're going to go to the Generate Silk Screen window. Now this window will actually place the silkscreen outlines and text labels onto the layers of the board, and then we choose which layers they go onto. So I'm going to add on the component labels and component outlines for the components on the top of the board onto layers 1 and 2. And we've got some components that have been flipped onto the bottom of the board, and so we'll have those on layers 3 and 4. It's always a good idea to separate the labels and the outlines between layers for future modifications. It will make your life much easier. You can control the height of the labels and the thickness of the lines that form the labels. So when you're ready, we just hit the generate button, and that will have generated the silk screen onto the layers of the board. So if we now turn on the bottom layer, well, we'll turn on just the top layer and the silk screen on the layers 1 and 2, we can see what we've got. And if we zoom in, you've now got the outlines for the surface mount components, and if we go to the text commands, we can just pick up the labels and move them out of the way, and you can rotate them again with the R button if you want to. Just picking up the labels and moving them out from underneath the middle of the components. And so now if we look at the properties of the artwork editor, we've now got the via layer and the top and bottom layer. They've all got some points on them, which means that there's information on those layers, and we've also got information on the silk screen layers. So if we now turn off the top layer and have a look at the bottom layer and the flipped components, which is only the one, and we can move the label for that one, and bear in mind that because that component's flipped, the text has been flipped automatically. So that's how the silk screen is generated. If you want to add additional text, you've just got the text add command. It goes on to the layer and at the size you specified in the dialog bar. So you might want to put on an issue number or something like that. And if you want it on the bottom of the board, you can insert it as mirrored text. The height is controlled from here, and the line size and the angle. You can actually rotate that text as you add it. And then you might want the same on the top of the board, but unmirrored. And we'll just lift it up above so that you can see it. Okay, that's just turned on the silk screen for the top and the bottom now together. Okay, as we've added some copper fill, it might be an idea just to run the connectivity checker again, just in case we've made some mistakes whilst we've been working, and again we've got no errors found. Another thing you can run is a silk screen error check, and this will tell you whether or not you've got silk screen text over vias or underneath component pads. This is all controlled from this window, bottom part of the window. And by running it, we've got a silkscreen check with 19 errors found. So if we have a look, what it's telling me that on the bottom layer, if we turn off these other layers so we can see what's going on, we've got the silkscreen mask too close to those component pins. So if it was important that you didn't have the silkscreen so close to the surface mount pins, you might want to think about increasing the silkscreen outline size for that component, and it's the same for the other layers as well. Just the outline is too close to the component, so we could run the check again and increase the clearance, decrease the clearance requirement. And this time we've got no errors found, so it's entirely up to you how close you allow the silkscreen to be to your component pins. But there's no errors on that board, and so it's ready to go to the output tools. There's lots and lots of commands that I haven't shown you. The highlighting commands, you can select a net and it will highlight all the tracks on that net. You've got region commands to pick up areas. Just lots and lots of flexibility within the artwork editor, and I could go on and on, but we'll be here all day, so I'm just going to move on very quickly to show you how you would output your files for photo plotting or printing once you've got your artwork complete. I haven't been doing much saving of the design whilst we've been working, so what we'll do now is this little asterisk alongside the job name indicates that changes have been made to the job and they haven't been saved. So I'm just going to right click and say save, and now all my work has been saved. So down in the navigator we've got a folder called outputs, and within there there's two subfolders, tasks and batches. So what we need to do is create a task for the artwork layers. We could say this is the top copper to photo plotter. Open it up, and then you change the settings. So we're going to go out to the photo plotter, and the background represents the film that the artwork will appear on. If we look at the setup, it basically goes out as RS274X. You've got the properties, number of decimal places and that type of thing. And then we look at the artwork layers setup, and we choose what we want to output. So do you want to include the board profile or not in the film, the key part regions? If you were doing spot drilling for a prototype board, then you might want to include the holes as well. And then you choose what layers you're going to output. Now I've got some colours and layers chosen from previous jobs here. So what we're going to output is the vias and the top pads and the top copper. They're going to come out in black. On a printer you might do what I've done here, and that's change the colours so that you get a colour print, but normally for photo plotting it's always set to black. But I mean, it's irrelevant with the photo plotter, it's going to come out as it comes out. Okay, so there's the board, and we can pick it up and move it. So if we want to move it down into the lower left corner of the design, zoom in a little bit, and there's the what's going to go out to the photo plotter. So we just hit the go command, and then it will ask me for a file name, top copper, getting started, so we can identify it later on. And then once we've set that task up, we can right click and copy it, and then right click and paste into the task folder, rename that task, and this is going to be for the bottom copper to the photo plotter. So we open this task up, change the artwork layer setup, because this time we don't want the top layer, we want the bottom layer, and that's what will appear on the bottom film. And then again we just hit go, and we'll call this one bottom copper getting started. And so you just create all the tasks you need for the silk screen. We can paste the one we just used, rename, top silk screen to photo plotter, open it up, change the layers, and this time we don't want any copper layers coming out, we want layers 1 and 2, which was the top silk screen, and then hit go. Right, so you set up your tasks for each of the films that you would want output, and just to speed things up next time, if we look in the batch folder and right click on new, we can create a batch process for all the photo plotting files, and basically we just transfer all the tasks into the batch process. And then when we run all those tasks, we don't have to sit and put in file names, because we'll have just set it up here. And then each time you just run that task, that batch process. Right, so I think that is a very, very brief introduction to XL Designer. I mean, I've gone through it very quickly, and you haven't seen all of the things that it can do, and it would take me a couple of days really to show you everything, but hopefully you've got a flavour for how easy it is to use, and you might have a look at an evaluation copy or come back and have a look at some other videos once they're placed up on the internet. Thank you very much for listening to me, and I hope I haven't bored you to tears too much. This is Hazel signing out from C-Trax Support. Bye bye.